Hi everyone, so this is still section 3.4. We just have like this bonus section that we're going to talk about. And in this bonus section, we're going to talk about something called compound inequalities. So what is a compound inequality? We're still talking about inequalities, so with a less than or greater than, or a less than or equal to, greater than or equal to same symbol. But now we're going to have multiple. We're going to have two inequalities joined by either the word and or. Okay, so we're going to talk about what it looks like if we have an and inequality, and then what it looks like if we have an or inequality. But basically, we're combining them. We're compounding them. There's two inequalities joined by either the word and or. So an and inequality, it says both individual statements of the compound statement are true. And, so it's like it's raining and it's cloudy. Both of those are happening at the same time. So when we graph it, the shading happens between the two numbers. So here's an example. It says x is greater than 5 and x is less than 10, less than or equal to 10. So guys, we can write this actually as saying 5, the smaller number, is less than x, and it's also less than or equal to 10. And what that looks like on a number line is if I have 5, 6, 7, 8, 9, 10. I have an open circle on 5 because it's just a less than. I have a closed circle on 10 because of the or equal to. And I shade between these numbers. And we can check, doesn't that make sense? X is greater than 5. These numbers are all greater than 5. But x also, both of these things have to happen. X also has to be less than 10. Okay, it's going to be between these numbers. Or is a little bit different. As long as one of the two statements is true, the entire compound statement is true. So it's only one of them, one or the other. Shading occurs outside of the two numbers. So here, in this example, it says x is less than 5, and we can draw this. So if I've got 5 here, I have an open circle, and it's less than 5. Or x is greater than or equal to 10. Closed circle here, and I shade in this direction. Okay? Or one or the other. Both of them don't need to be true, right? My answer to this could be 11. That could be an answer because it satisfies this inequality. Or my answer could be 4 because it satisfies this inequality. As long as one of these inequalities is true, the whole entire compound is true. So then let's check out how we're going to write and graph compound inequalities. So as we read, we want to start to write. It says a number is greater than -8. A number is greater than -8 and less than or equal to 4. So once I write that, I realize it's an and statement, and I can then write it as -8 is less than x, which is less than 4. Less than or equal to 4. Because x is greater than -8, this is true, x is greater than -8 and less than or equal to 4. And then once I put this on the graph, I'll have an open circle on -8, a closed circle on 4, and then it's an and statement, so everything, you can also graph like this, everything between them is true. Let's check out the next one. A number is greater than or equal to 3, and it's literally saying, or a number is no more than -8. That means it's less than, no more than -8. It's an or statement. So when I go to graph it, I'll have a closed circle on 3, and it says x is greater than 3, or x is less than or equal to -8. So it'll look like something like this. And then we're going to practice writing the inequality. So as soon as I see this one, I know it's an and statement, and I see that the numbers are between -4 and -1. So right away, I set up -4 is less than or equal to x, which is less than -1. That's an and statement. We could go boom. It's always going to be this setup, guys. Some number is less than or equal to x, which is less than or equal to another number. This right away is an or inequality because there's two different parts. And I just think about what this represents. So I have an x, and then I've got a point on 3, and where is it shading? It's shading less than 3. Or I've got an x, some variable, and 6, and where's the shading greater than or equal to 6? Okay? Really understanding what the graphs represent. So how do we solve compound inequalities? We've got some steps here. Determine if you are solving whether it's an and or an or. And then we're going to rewrite the inequalities if needed and solve each part of the inequality using inverse operations. So sometimes we're going to rewrite, and you'll see what happens when we do that. Then we'll graph out a number line and determine the shading. So let's check this out. Number 1, our very first step that we need to do is figure out if this is an and or an or. Well, as soon as I see it set up like this, I know it's an and inequality. And when we have an and inequality, what that means is there's a couple different ways we can solve this actually, guys. I'm going to leave it just like this. When we have an and inequality, I want to just focus on getting that x by itself in the middle. So when I have an and inequality, focus on getting that x, that variable alone in the middle. So that means I would divide everything by 3. Negative 3 divided by 3 is negative 1, which is less than x, which is less than or equal to 3. Once that variable is by itself, I have my final answer, my final inequality, and then we'll graph this. Open circle on negative 1, close circle on 3. It's an and inequality. I'll connect our points. Any solution between negative 1 and 3 would satisfy this inequality. That's what it means. Notice here right away they're telling us it's an or inequality. When it's or, we're just going to solve these separately, guys. So I'm going to divide both sides by 2. X is greater than 4 is an answer, or solve this one for x. Divide by a negative, be careful. X has to be less than or equal to negative 1. There's my answer. I put a open circle on 4, and it goes this way. And I put an open circle on negative 1, and it's less than. It goes this way. Nice job. Let's check out another one. As soon as I look at 3, I realize that's an and I'm going to solve this for x, getting x alone in the middle. I'll subtract 9 on both sides, so all sides. I get negative 9 is less than or equal to negative 3x, which is less than 15 minus 9 is going to give me 6. And then I'll do one more step here. I'm going to divide by a negative 3 to get that x alone. Be careful, guys, right? I'm going to divide by negative 3, so I'm going to have to switch these signs. Negative 9 divided by negative 3 is 3, is greater than or equal to x, which is greater than negative 2. As soon as I see that, I'm going to flip this around because I want to make them all have less than signs. I also want to have this least number on the left. These numbers should go smallest to greatest. So I'll go negative 2 is less than x, which is less than or equal to 3. That's my proper final answer. And when I graph this, I'll have an open circle on negative 2, a closed circle on 3, connect our points. And then our last one is an or statement, so I'll solve both of these separately. Subtract a 1, divide by 4. Or, I'm going to add 4, divide by 3. Here's my answer. So that means my answer is going to be less than or equal to negative 3, or my answer is going to be greater than or equal to 3. Okay? Great job, guys. That is your notes on how to solve compound inequalities and or inequalities.